This is a quick demonstration of the digital metronome. This is a circuit setup mounted on a breadboard. We have an esp32 here with two buttons, a potentiometer, an OLED display which is 128 times 32 inch size, and a piezo buzzer which is being regulated by a 100 ohm resistor. This is a programmer for the esp32. So I will turn on the esp32. You notice that when it's turned on, it defaults to playback mode, like it starts playing immediately. But this is something which can be programmed, and we can have other behaviors, like maybe it should not play until someone initializes it. So we have two buttons. This is a button which currently we're in the playback, which is the main display. This is the default display, and it shows the BPM which is currently in. It shows the status of the metronome, whether it's playing or it's paused. And then the S4, it's the custom sets, the rhythms. So it will cycle between the four sets. So we have S4, then it will cycle to the S1, S2, S3, S4, depending on what kind of rhythm someone's playing. So every set can be set using, we can set the parameters, which is a BPM and the time signature for each set. So to go to the setting mode, I will press this, but I will long press it, like maybe hold it for 2 seconds. So 1, 2. Then it gets into the setting mode. So this is another screen. It first shows set 1, and then the indicator points to the BPM. We can either increment or decrement the BPM using the potentiometer. Maximum currently is at 240. I've set the range of the BPM from 40 to 240. So let's say I put here like 160. Then I will press the same button, but now I'm not long pressing it. I'm just pressing it normally like this, and it's going to cycle. It's going to go to the time signature where we're going to set the beat. So maybe we want 1, and then press it again. It's going to cycle to the notes, which is the denominator. So maybe it can either be 1, 2, oh sorry, here it was 160, and then this is 1. So here maybe we say 4. So this range can be changed, can either go up to 1, 2, 4, 8, 16, or the range here currently it goes until 1 to 8 bits, but we could take it further. So after doing the setting for set 1, we're gonna press the other button now, and this, when we press it, we save the settings for set 1, and then it goes to the second one. And this will also save it, and even when you turn off the esp32, when you turn off the metronome, when you turn it on again, it's gonna default, it's gonna resume to the values you set in the last session. So I will press it, it goes to set 2. Then we will have the same process, either BPM, beats, then we regulate it, we set with parameters with this, and then just like that. So let me assume I've already set, and we'll just save all of it, set 3 and set 4. So when we reach set 4, when we press it again, it's not going to go to set 1, it's going to get back to the playback mode, which is the main display the screen we started with. Otherwise, currently we're just using the potentiometer, but later in the day we will change it to a rotary encoder, and that rotary encoder comes with a push button here. So we might could as well use this push button on the rotary encoder to start or stop this, to change between setting mode and the other one. So let me just press this, and then it starts playing. So currently that's set 1, then it changes to set 2, and it goes like that. It also displays what you set when you was in the setting mode. These are just the counts and the BPM. You also notice the sound of the piezo buzzer is quite low, and initially I thought it maybe it's insufficient power, because I was powering it with a programmer, which can only supply 200 milliamps to the esp32. It can only 200 milliamps, but but then I changed it, and now I'm using the USB-C from the esp32, which is the default way of powering an esp32, and this should be around 500 milliamps, but still we have a lower volume on the piezo buzzer. So this is one challenge we're facing, because you cannot tell, it's hard to tell the difference between the different rhythms, and you cannot feel the transition very well, like from the video which was sent, the click bit. So there are potential issues which need to be addressed here. Could be perhaps we need to amplify the buzzer with maybe a transistor, because currently we're just using PWM at 100%, and since we are also regulating the piezo buzzer with a 100 ohm resistor, maybe it could limit the pitch, the pitch volume. So that's why the sound is quite low. So another thing is, so the range of the BPM currently is from 40 to 240, and we have the signature and the note value. These are values which can be custom set. One thing which arises is how does the transition work, let's say from changing from set 1 to set 2 to set 3, because I find that some other metronomes they have different approaches. Like there's a variety of approaches. Some of them just use a set value, like a duration. So maybe one set would play for like just 10 milliseconds, then switch. But then you have other metronomes which use the same internal BPM, like from the way we calculated the intervals. We say like 16 beats per set, which will equal to 4 measures, 4 over 4. So some of them use that internal just to set. So you would have a dynamic bit, because it will depend on what BPM you set for every set. So let's say for 240, it could only play for 16 seconds. Then if you set 2 to like 80 BPM, it could play for 8 seconds. So this is an issue which needs to be addressed, and especially with the client requests. Other than that, the frequency we're now using, it's 4000 hertz, which is the fast bit frequency. Then we have the regular bits, which should be now, it's 3500 hertz, which is quite high, because maximum we could go up to 5 kilohertz using the esp32. But still we have this low volume. We will try to use another buzzer, like a more powerful speaker, maybe something like this. But if we need like a very quality sound, like the way we see those metronomes on production, we might need to play around with the sound. We need to amplify it or filter the noise using low pass filters. So those are potential remedies to counter this. So thank you.